A linked list is a collection of data elements called nodes, in which the linear representation is given by links from one node to the next node. A linked list does not store its element in consecutive memory locations, and user can add any number of elements in it. The elements in a linked list can be accessed only in a sequential manner. So, in this, we can perform insertion and deletions at any point in the list. In simpler terms, if we say, then the linked list is a data structure which in turn can be used to implement the other data structures. Thus, it is the building block or the fundamental of the data structure. And using linked list, we can implement stacks, queues, etc. So here are the basic terminologies. The linked list consists of a nodes, a sequence of nodes, and these nodes are made up of data fields and the pointer. And the pointer contains the address of the next node, that is, as you can see, this is the data field and this is the next field. So now here we have the difference between the arrays and linked list. So an array is a collection of elements of a similar data type, while a linked list is a collection of objects known as a node, where node consists of two parts, data and address. So array elements store in a contiguous memory locations. Like array stores the data elements in continuous memory locations, but in linked list it can be stored anywhere. Like if there is a list, this is a list, and we have to store a new data, so we can store it any position, like in the beginning, in the end, and middleware, anywhere. So the arrays works with a static memory. Like array has, as you all know that that array has fixed memory, but linked list works with dynamic memory. It allocates the memory dynamically. The memory size is fixed and cannot be changed at the runtime. In array, we cannot change the size of the array. Like if we need more space and more, we have to store more data in the array, so we cannot do at runtime. But if we want to add new data elements in the linked list, then we have uh, uh, dynamic memory allocation. Like in this, memory size can be changed at the runtime according to requirements. As you all know that the array elements are independent of each other. Like we can access any kind of elements from anywhere, but to access an element in the linked list, we should have the address of the next node. And to access a node, as you know that, like linked list consists of nodes, and in each node contains the address of the next node. So if we want to access a node, then we have to we need the address of its previous node, so that we can access that data value from its previous node. So now the array takes more time while performing any operation, and linked list takes less time while performing any operation. Like if then accessing any element is faster in array, while accessing any element in is slower, as it starts traversing from first element of first list. Like as you all know that if you want to access an array of 1 to 3, like given an array 1 2 3, and you have to access any element like 2, so you can directly access it with its position. But if you want to access any element in the list, then you have to start from its first element, so that you can reach to that particular position of that node. So this is why the accessing element is slower in linked list while it is faster in array. As you all know that previously know that memory is allocated at compile time, but memory in list is allocated at runtime. Memory utilization is inefficient. Like if you have size of array 5, but you have stored only 3 values, then remaining two memory spaces are wasted in the array. But if we use linked list, then it is efficient. If we want three memory spaces to store 3 data values, then we can easily store 3 data values. But if we do not want any data value to store, then it will store to that particular it will utilize only that memory space. In array we are wasting two extra memory spaces, but in linked list we are not wasting any kind of spaces. That's why the memory utilization is efficient in linked list while it is not inefficient. That's why the linked list is more useful and widely used in data structures. So this is the concept of linked list.